To start this video, the second part of lesson 5, we're going to go back to lesson 3, a blast from the past, and solve a fractional equation. As I said earlier, we do have 4 fractional equations you have to solve. So I think this is our third one on the first page, and this is page 2 of the practice test. That's our second one, that's our third, that's our fourth. So I'm going to help you with the LCD because I want to make sure you guys are clear on how to do it. So we learned during the lesson 3 videos to find the LCD, you pick out the largest number and start doing multiples. So start with 10 times 1. Does 2 go into 10? Yep. Does 10 go into 10? Yep. Does 5 go into 10? Yep. Does 2 go into 10? Yep. Done. Now let's say one of these had been 4. 4 doesn't go into 10, so then my next one would have been to do 10 times 2, 20. Yep, that goes into 20, that goes into 20, that goes into 20, and if there had been a 4 here, that goes into 20. So you just do multiples till you find one that it goes into. This one and this one, it was the largest number already. But if it's not, then you do 4 times 2, 8, and then 4 times 3, 12, and then 4 times 4, 16, till you find one they all go into. Same here. 10 times 1 is 10, it worked. But if it didn't, then you do 10 times 2, 20. See if that works. 10 times 3, 30. See if that works. And then just to remind you, every numerator, whether it's a fraction or not, in this case they're all fractions, gets multiplied by 10. Okay, so go ahead and shut down the video and finish up that problem. See how you do. And then check back with me and we'll find the answer together and grade yours. When we were doing this in lesson 3, I said to make a little longer line and just think of it as a multiplication than a division problem. 10 times 1 is 10, divided by 2 is 5. And don't lose your x. I see that happen a lot. Students get so focused on this, they forget. Minus 10 times 1 is 10, divided by 10 is just 1. Or you could have even done this. And then you see that it's minus 1 as well. Next term, 10 times 1 is 10, divided by 5 is 2x, plus 10 divided by 2, 5. And that, to me, like I said, is one of the most beautiful things in mathematics. To be able to take that ugly thing and solve this easy equation to find the answer. Like I said, you will never have to solve a fractional equation again in your life, because step 1, get rid of those fractions. And then you just have a simple little 2-step problem. X's move to the left, so since we're crossing the equal sign, do the opposite. And all x's are now on the left. All constants now need to move to the right by doing the opposite since we're crossing the equal sign. 3x equals 6, divide by 3, divide by 3, x is 2. And I had someone ask me last semester, you never showed us how to check a fractional problem. Do you check it the same way? And the answer is yes. So I'm just going to get out a separate sheet of paper just to show you it is actually just as easy as checking a whole number problem, because you're going to use your calculator, and the calculator does almost all the work for you. So we learned the first step for checking is to write the original problem, because if you have extra time on your test, go back and check any problem that says solve. That means it can be checked. So what did we find for our answer? X equals 2. So we plug it in 1/2, and because it's right beside, that means times 2. minus 1/10. And I want to know, will that give me the same answer as 1/5 times 2 plus a half? After that, it's all done on your calculator. When I ask for a check, though, I do require these 2 steps. So make sure before you go to your calculator, you've shown the original problem, you plugged it in, then you can put the answer to this side there and the answer to this side there after the calculator. So don't just do it in your head or pick up your calculator and start doing it. You need to show me how you got those answers on each side. And this is the step I need to see. After that, piece of cake, as long as you know how to use your calculator. So we do 1 fraction bar 2 times 2 minus 1 fraction bar 10. And this calculator has order of operations built in, so I don't have to do this piece and then this piece. I do the whole left side and then I hit enter. And that comes out to be 9/10. And then I do the whole right side and hit enter. I don't have to do pieces. This knows order of operations. It knows to multiply first and then add. And that's why I love this calculator. It's so easy to use. 1/5 times 2 plus 1 fraction bar 2. Ding, 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 ding. There you go. Love, love, love it. So was that easy or what? So fractional equations aren't any harder to grade than regular equations. So no worries. Just plug it in, show your work step, and then do each side on the calculator and show me what they come out to be. And because they are in fact equivalent, then we can go back and put 2 in solution sets. I love the solving test myself, because who doesn't want to be able to check all the problems before they close out their test and submit it? I would think everyone does, because I know I make errors. I'm guessing everybody does. I've had one person actually get 100 on all my tests in my 126 class. One person in 39 years. One person. So there are some people, I guess, that don't make mistakes. Okay, moving on. Come on, Kim, quit talking so much, right? Couple more translate before we get started with the word problems. So again, you already know all this, so go ahead and do that. So I just kind of made this page look more like the test. It has translation, then it has some word problems. So the last page was just as a review, the last video. This is where we're putting all that review to work. So turn off your video, do ABC, and then come back and we'll check them together. For the first one, 4 times a number, and I put commas in to help you with the separating of the words, because I know it's a lot easier when you know where to stop to do your translations. So 4 times a number, and I'm just going to remind you again, in ALEKS they tell you what letter to use for the number, so be sure and read the directions carefully. Increase by, there's some words we saw on the last page. Increase by means added by 6. So increased means add, decreased means subtract. And of course you can also write it as 4x plus 6. Same thing, whether you put the times in or not does not matter. So let's just put an or there. Product. Ooh, we know from our translations, the minute we see product, we do 2 parentheses. Sometimes one or both of the parentheses will be dropped off, but that's there in case we need them. And then we learned, because this is one of the key operation words, we have to look for the word and to know what goes in the first parenthesis and what goes in the second parenthesis. So the first parenthesis is just going to be 4. So in your head you should be going, okay, I can drop that one off. Don't need parentheses around a single term. A number, there's increased by again, increased by 6. So let's use in this time. So I would rewrite this, and notice this one does not say simplify. So don't do your distributive. You're just translating like Alex is going to have you do. So really the only thing you need to do to clean it up is drop those parentheses. And it's actually, I don't know if Alex would count it wrong, but legally it's not wrong to put the 4 in parentheses. We just usually don't put single terms in parentheses. So this is the best way to write it. And like I said, don't simplify because this one doesn't say simplify. Quotient, oh yeah, we're all over this. Had tons of those. And because it's a keyword, we look for the word and. So we know what goes on top of the fraction and what goes on the bottom of the fraction. So a number, there's decrease by, that means subtraction. So let's use t this time. T minus 4 and 9. And I bet you guys are getting really good at those by now, right? We've been doing them pretty much the whole chapter. But I like to keep reviewing because I know for a fact, the more you review, the better you're going to remember it. So one day you'll thank me. Thanks for reviewing so much. Okay, so we have some translation word problems. These first 2 are translations and then the rest are regular word problems. I did put one translation word problem on the test, so these are both good to study, and I think we've done one on a previous section too. But the only difference here is they also want you to solve because it says find the number. So that's the difference. It's not just a direct translation stop. It's translate words into numbers, then solve. So 4 subtracted from, keywords. Still have to follow all those rules even though we're solving now. That means this goes first. 6 times a number. And 4 is being subtracted from 6 times a number. Then it says is the same as. That's another word for saying is equal to. So that just means an equal sign. So 4 subtracted from 6 times a number is equal to that same number subtracted by 9. Not from 9, by 9. So that's the difference between from and by. From means that has to be first. By 9 means it is second. The number subtracted by 9. And now we just have a little 2-step equation. So actually the solving part of these is easier than all the equations you've already done. That's the easy part. So the new part is writing your own equation. So to solve this, I need all my x's on the left because there's no parentheses or like terms. So I do minus 1x, minus 1x. And that gives us, gone there, 5x minus 4 equals negative 9. And let's just move it up here since I'm writing like a giant and can't fit it in. 5x minus 4 equals negative 9. Okay, now we need everything without a variable, all the constants to the right. Do the opposite since we're crossing the equal sign. And we get 5x equals, when the signs are different, we subtract, keep the sign of the larger. And last but not least, to get x alone, we do the opposite one last time. The opposite of times 5 divided by 5. So x equals negative 1. And there you have it. Find the number. We did. Okay, example 3 is almost exactly like it. So now is your chance to practice on one all by yourself without any help. So go ahead and shut the video off and come over when you're done and we will check your work. we have 3 times the difference. Ooh, I had you highlight this in your notes because I told you this was one of the most difficult translations for students. So those 4 words mean this. And the same if it said 3 times the sum, 3 outside, plus sign inside. So 3 times, and because the difference is something minus something, it must be in parentheses because it's 2 terms. And then because we have the key operator word there, difference, we look for and to see what goes in front of the subtraction and what goes after. A number goes in front, 5 goes in the back. So a number before and, 5 after and. And here's that wording again, is the same as. Is the same as, which means equal. Twice the number decreased by 3, not from 3, by 3. So that would be 2x minus 3. So how'd you guys do? I'm hoping these are super, super easy for you by now. This test isn't too far away. What are we on? Lesson 5, and we have 7 lessons total. So yeah, test isn't too far away. So I hope you're starting to feel more and more confident. So 3x minus 15 equals 2x minus 3. We always have to clear parentheses first, and all x's go on the left. So we have to cross the equal sign to get that over there. So do the opposite. And that's going to leave us with 1x, or just x, minus 15 equals negative 3. So 1x minus 15, that's gone, equals negative 3. Nice. One-step problem from there. Constants on the right. And so we have, by doing the opposite, 15 minus 3 is 12. Love it. These are really fun, huh? I could do a whole test of those and be real happy. Okay, sorry. I forgot to turn my phone off. It's off now. When I'm done doing videos, then I forget to turn it on. When I am doing videos, I forget to turn it on. I'm a mess. Okay, so here's those consecutive integer problems. So 3 consecutive even integers. So I immediately write 3 even integers. I don't turn my page and look back at my notes. I practice deriving them on my own. So this is x. To go from 2 to 4, you add 2, x plus 2. To go from 2 to 6, you add 4. So you can call this your first even, second even, and third even. And I know some teachers are very particular about variable statements, so I'm going to write it out too. I shouldn't have done that shortcut. First even integer, x plus 2 equals second even integer. And you know from the wording from ones we did earlier, just like this one, I have to know which one's the first and which one's the third. So you want to label them just like we are. X plus 4 is the third even integer. After that, it's a direct translation problem. So that's your part. After that, you just translate. Sum means add. First plus third. Well, the first is x, and the third is x plus 4. So the first integer plus, because of the word sum, first plus third equals, is means equals 68. And do you know what's really weird? When I put this on a test, so many students miss it because they write x plus 4 equals 68. And I'm saying, where did it say the third integer equals 68? It didn't say that anywhere. But they forget to add the x in front. So you bring down the first, then you bring down the plus sign, then you bring down the third. But yeah, I've seen that several times where students just write x plus 4 equals 68. Well, then that means you think the third number is 68. It doesn't say that. It says adding the first, which is x, and the third, which is x plus 4, gives you 68. So be careful with that. Okay, now we're actually going to be solving. So to solve this, we have to combine like terms. So we get 2x plus 4 equals 68, and it's a little two-step equation. X's are already on the left, so we move everything without an x on the right. 2x equals 64. 68 minus that. And then opposite of times is divide, so we get x equals 32. And this is where I find a lot of students that aren't, what do you call it, word problem aficionados. They get here and they don't know where to go. That's why we write this. You should never go, oh, I wonder what I do next. That's why the variable statements are there, to help you answer the questions. You've just found the value of x. Every x in that problem now has a value of 32. So you should never go, what am I going to do next? You immediately take the x you found and plug it into your variable statements. So I can see the first number is going to be 32. 32 plus 2, I can see the second number is going to be 34. And 32 plus 4, the third number is going to be, what is that, 36. And once again, there is no room for this problem, so I'm just going to come down here. So 32, 34, and 36 are my three consecutive even integers. How can I check those? Well, it says the first and the third add to 68. First is 32. The third is 36. Ding, ding, ding. So once you find your numbers, then you can fit them into this and make sure it makes sense. Is 32 plus 36 68? And you can see that even without a calculator. So every x in the problem becomes 32. So the first integer is x, it's 32. 32 plus 2, the second integer is 34. Fill this x in with 32. 32 plus 4, the third integer is 36. I was just going to write are the three even integers. So, not bad, right? I don't think that one's bad at all. Okay, this one, we've done one like this too. It was when we were doing the integer problems, wasn't it? No, I think it might have been the Missouri problem. No, remember when we did the river? Yes. So a 9-foot rope is cut into 2 pieces. So X is the first piece. The second piece is the total minus X. Because if this piece is 2 feet, the second piece is going to be 9 minus 2, 7. If this piece is 5 feet, the second piece is going to be 9 minus 5. So you always subtract from the total to get the second piece. So just keep that in mind as we do this one. So we have an 18-foot rope And it looks like it's cut into 2 pieces. So we know the whole rope is 18. And you guys remember about the word than? How I told you a lot of word problems have than, and this is one of those. So the minute I see than, I look what's after it, and that's my X. That is such an awesome way to find your variable, because people will read this and they'll have no idea where to start. But if you're educated about the word than, whatever follows than is X. And you can call it any variable you want. In this case, X is a good one to use. 5 times longer than the shorter piece. So I go to the shorter piece and I put X. And it says the longer piece is 5 times longer than the shorter. So 5 times the shorter. I used to love to give these problems in geometry in high school, because this was it was called the segment addition postulate in geometry. I can't believe I remember that. It's been so long since I've taught high school. So it says that when you know the whole, you add the segments and set it equal to the whole. Segment addition postulate. So let's go back and just make sure everybody knows where the variables came from though. Whatever follows than is always X, so shorter piece is X. Then it says the longer one is 5 times the shorter, so that's why I called it 5X. And then the segment addition postulate says the small piece plus the large piece equals the original piece, which was 18. So look at that easy equation. I always put this on my geometry test whenever we had that postulate. Great problem. Shows a lot of understanding of math. How do I represent your variables, and to know that the 2 parts make the whole. And then it's just a one-step problem. 6x equals 18. Divide by 6. And just like on the last problem, and every word problem you do from here on out, every X in this problem now has a value of 3. Every X. So I can go immediately to the picture and know what the 2 pieces are. This is 3, and this one's going to be 5 times 3. So every X gets 3 plugged in for it. Not just this X, every X in the problem. So I can see the shorter piece, and this is foot, right? Yep. So the shorter piece is 3 feet. And the longer piece, 5 times 3, which is 15 feet. And then all I have to do to check it, 2 things I can do. Is this piece 5 times longer than that? Yes. Do the 2 pieces add to the whole? Yes. There you go. Fun problems. I wish they always stayed this fun and easy. Okay, 7's a little bit quirky, so I want to do that one with you. If you want to try it, you can. You can shut off the video and try it. But I want you to try 6, very much like the one we did, because right away when I skim down that first, I go, than, my keyword. Okay, so write your variable statements, write your equation, solve the equation, and then make sure you answer the questions. So go ahead and take a couple minutes, shut off the video, see if you can do that all by yourself. Very typical problem for a test. This one or this one, both good. And so is this one, and so is this one. Remember, 1/3 of your tests are word problems, so you're going to see a lot of them throughout the class. So you just get comfortable with them. You don't freeze. You're like, oh my gosh, we've done 1,000,000 of them in the notes. I'm great at word problems now. Okay, so go ahead and shut it off, and then we'll check it together when you get back. Okay, California had 21 more electoral votes than Texas. Boom. There's my X. But calling Texas X is kind of silly. Let's call Texas T. So whatever follows then is your X. Not 3X, not negative X, just X. Or in this case, we'll use T. So T equals number of electoral votes in Texas. So Texas electoral votes. I should have said number, but oh well. Electoral votes. I'm just trying to shorten it a little bit since we don't have very much room there. So look for than, just like this one. Shorter piece after than, call it X. Texas after than, call it X, or in this case, T's better. California had 21 more. Well, we know from the first page of this packet, or from this lesson, that more means plus. So Texas plus 21. Everybody get that part? I'm sure you did. Texas plus 21 equals Cali. So right there, that's the most important part of the problem. You haven't even written the equation yet, but you get those two steps wrong, you can't write the equation correctly. So take your time with your variable statements. I've given you a lot of hints and tricks on how to write them, than being the biggest one. Then I read the next sentence and I catch the key word. Total is 89. So total means I need to add these two. So Texas's votes plus California's votes equal 89. So total always tells me to add the number of votes in Texas plus the number of votes in California equal a total of 89. And then we just solve away. So 2t plus 2 equals 89. Minus 2, minus 2. Okay, I don't like that one bit. Oh, that's why. Because I'm going, wait a minute. I'm going to get a decimal. I lost the 1 on 21. Now I'm not going to get a decimal. But see, my mind's always checking to make sure the problem makes sense. And I'm like, how are they going to have, because if I would have subtracted 2, it would have been 87 divided by 2. That's a decimal. We can't have a decimal number of electoral votes. So that was my hint to check my work. I'd lost the 1 on the 21. So now it's going to work just fine. So 2t equals 9 minus 1 is 8. 8 minus 2 is 6. Divide by 2, divide by 2. Every t in the problem, and that's probably one of the most important things to learn, because students don't know that when they come into my class. They think t's 34 and it's just that t. Every t in the problem is now 34. This is 34, this is 34, this is 34, this is 34. Every t. So when they ask us find the electoral votes for each, well, that's why we always write our variable statement first. And all I have to do is go right there, plug it in, and I have my two answers. And I see I have my paper a little bit big. One time oops, let me make it just a tiny bit smaller so it's all fitting on the paper. There we go. So we have, again, I'm going to have to encroach on this problem. So Texas has 34 votes. And California has 34 plus 21, which is what? 55 votes. And Check and see if it gives you 89. 5 plus 3 is 8. 4 plus 5 is 9. Boom. There it is. So than is a miracle word. It's amazing because it helps you so much with word problems. It guides you and lets you know what the X is. Okay, this next one is a type of problem that you always want to make sure you draw a picture for. It's a triangle. I'm going to draw it nice and big so that I can run out of room when I'm working my problem again. So, little trick of the trade. Another word that means than is like as large as small as. So it says the second angle of a triangle is twice as large as the first angle. So that's like saying twice than the first angle. So that's kind of a hidden little tricky word for than. So when I read this, my mind just calls that than, and I go, oh, I know what X is now, because what follows than. So than doesn't, like in the English language, totally transfer over twice than the first angle, but any comparison word like than, as small as large as big as, those all are comparison words like than. And I had to kind of like teach myself that as I went along. So I'm like, I see than there, but I don't see it here. And then I realized that I could put than in there and it's the same thing. So that draws me to the conclusion that the first angle must be X because it's the one that follows than. So you might want to label your three angles, because they're going to ask later, find the first, find the second. This one's 3 more than the first. This one's 5 less than the second. So you want to know which one's which. So write in the first angle. And X, I think, is appropriate for this. So I'm going to call that X. So the first angle of the triangle is what it's comparing to, so call it X. Then you go back and read your sentence again to find out what the second angle is. The second angle is twice the first. Oh, that's easy. Aren't you glad now you had so much practice with the translations? It makes word problems so much easier. So twice means 2 times the first. The third angle is 40 more than, we know, means plus the first. So the first is X. It's 40 more than X. So we would write, best way is X plus 40, but if you wrote 40 plus X, it's not wrong. I love this problem. I would put this problem on every test I make for the rest of my life if I could. I just think it's a great problem. You kind of got to be a wordsmith, have to know a little bit about geometry. It's just a great problem. So hopefully everybody's good with that. X is the first angle. Second angle is 2 times X. And the third angle is 40 more than X, which is X plus 40. So you do have to come into this problem with a little tidbit of knowledge. So you have to know that from geometry in high school that the 3 angles of a triangle add up to 180. So angle 1 plus angle 2 plus angle 3. This was a theorem in geometry in high school. The 3 angles of a triangle must add to 180 degrees. If you didn't know that, you wouldn't know what to do next. You'd be like, So you do have to come back in with a little background information. So the 3 angles of a triangle. So angle 1 will be X. Angle 2 will be 2X. Angle 3, X plus 40. And after that, piece of cake problem. And that's why I like it. Because it's easy to translate. Hopefully you remember that from geometry, or you will now. And then you just plug it in and solve. So put ones in front of your x's to help you with combining like terms. So 4x's plus 40 equals 180. And then we have our x's already on the left, so move anything without an x to the right, and we get 4x equals 140. Divide by 4, divide by 4. And do you all know that dividing by 4, don't really need a calculator, you just cut the number in half twice. Cut it in half, 70. Cut 70 in half, 35. Somebody taught me that trick and I'm like, that is excellent. I love it, not having to keep picking up my calculator. So dividing by 4 is just cutting the number in half twice. Half is 70, cut 70 in half, 35. So I know x is 35 and my label for this one is degrees. Every x in this problem is now equal to 35 degrees. So you can move through the problem, put 35 here, put 35 here, and put 35 here. And then you can easily answer your questions. And like I said, that's one of the hardest things. Students get this, they have no idea what they found. It's every x in your either variable statement or in your picture. So I can see angle 1 is going to be 35 degrees because it's just x. Angle 2 is 2 times 35, which is 70 degrees. And angle 3 is 35 plus 40, which equals 75 degrees. And then next thing I do is just make sure those three add up to 180. 35 plus 70 plus 75, boom. So there's my 3 answers. I really like that problem. It's a good one. Okay, that's the end of the first part of lesson 5. We'll start the second part in the next video.